So those aren't even your real parents.
Oh, Barry.
Yes, they are. Hold me back.
You might could have guessed the movie even before you saw this video based off the title. We are going to work with an apiologist. What do apiologists study? They study bees. So this is the bee flowers data. We have how much pollen the bee had, how much time it spent at the flower. There's also a column here for the color of the flower, which you are not required to use, although you should at least notice that it's here. There could be some errors in the data set. I'm not saying that any of them are actually visible on the screen right now. What does the apiologist want to do? They want to predict the amount of pollen because it's really hard to measure pollen on a bee. So if they give you this data set of bees that they have measured pollen and how much time that bee spent at the flower, can you get to where you just predict how much pollen is on the flower totally based off the time it's spent on there? What's the rubric say? Well, you need to turn in the report, title, intro. That's always important. Notice it's 4 points. And we're talking about what's your goal as the statistician and why is there value in figuring this out? Why do we care about bees? If you've seen the movie, it's because the whole planet will die. Yeah, we don't really care. It's all about the honey. What program was used? That was a joke. Scatter plot, check for errors. There's a little hint. You are going to have some errors in this data set and you have to fix them in order to get the right values. Do a test with a p-value, and whether you reject or fail to reject is based off your alpha, so you should tell the client what alpha you're using, even if it's the same 0.05 everybody else uses. Now, if it's not significant, in other words, if time does not help predict pollen, that does not mean you cannot make predictions. It means it's going to be harder. You need to figure out what would your prediction be if knowing the time wasn't helpful. That's if it's not significant, and I'm not saying that it's not, I'm just saying if. R squared, the standard error. Justify your model was appropriate. How do you do that? You mention that you looked at the residuals, and the residuals show you that the model is appropriate. It's not about sample size. It's not about normality, although the residuals do show normality, so I guess that's in there. But you need to have some mention of residuals. You'll notice this 10 points is going to increase as we go further in the class because lots of students forget this, and it's not okay to forget. So down here, some residual plot. Do you really need to include the residual plot? No. I decided to put this in the rubric simply because so many students were not realizing the importance of looking at the residuals. Because we're working with two-dimensional data, it seems silly right now. I get that. But I really need you to understand that residuals are how you prove a model is good. Not because it had a high R squared, not because the standard error is low. Now there is color. If you want to move ahead, the next chapter talks about how to handle categorical variables. You're not expected to use color in your analysis now. But if you don't, you should at least mention, oh hey, color's a part of this. I'll bet if we looked at color, we could get more information, better results. So at least a mention that it could be important in there. Explain all the output. This is code for don't copy and paste stuff out of R, because that's not allowed in this class. Higher level stat classes, maybe. Here, no. Conclusion summarizes the findings. And remember that even if your score is low, that means you're learning what we're looking for in this class. You still get 100% in the grade book, as it says in the syllabus.